So this is the next essential fatty acid that you found. What is the scientific name for it?
Pentadecanoic acid.
Okay, we'll just go with C15. And so one of the things that I, want to highlight on the science of this too is you have these fatty acid chains basically, right? And there's even numbers and odd numbers of them. It sounds like the odd number ones are healthier than the even number ones. And why is that?
But what we now know is there are a couple reasons. One is that when saturated fats are metabolized, they're always metabolized by 2 carbons. So it's 16, 14, 12. And so they're always an even chain fatty acid in general stays even. And when it gets metabolized down to acetoacetic acid, which is pro-diabetic, while the odd chain ones are metabolized down to C3, which is propionic acid, which is anti-diabetic.
Dr. Stephanie, thank you so much for joining me today. I really appreciate you being here.
Oh, Dr. Shaw, it's great being here.
Yeah. And, I've been looking forward to this conversation because I've been taking Fatty 15 for probably close to 6 months now. And I feel better on it. I really do. I don't know if I'm just convincing myself of it, but it does. I feel like there's so much great science behind it. I just really want to dive into that with you. So thanks for coming up to do this.
Oh, thrilled to be here. I like how you use dive in. That's going to
be
relevant here in a
dive
second.
In, exactly. All right. So there's a lot to talk about here. But first of all, I think it's important for people to understand how you came upon this discovery, kind of your career path as a veterinary epidemiologist, right?
Right. Am I like your fourth that you've interviewed, right? This month.
How many veterinary epidemiologists are there in the country?
I don't. There's probably maybe 50 of us.
Wow.
So not
rare
a lot.
breed.
Rare breed, exactly. Yeah. So as a veterinary epidemiologist, actually, when I was in undergrad, I decided I wanted to become a disease hunter. So I read Laurie Garrett's book, The Coming Plague, and I was like, oh my gosh! And I was this pattern recognition nerd. Like I'm not good at a lot of things, Darshan, but I'm good at recognizing patterns. And then I learned that there was a career in that, which is epidemiology,
right?
So read Laurie Garrett's book, and I thought, oh my gosh, I want to do that. We look for patterns, figure out diseases, and then most importantly, how to fix them and prevent them. So went into met a physician met a veterinarian who was an epidemiologist, and he said, you should go to veterinary school because you're going to learn diseases in 8 different species instead of 1, and you'll really understand disease.
So makes sense.
Yeah, so I thought, well, that sounds great. So I did that. I went to veterinary school at Tufts, and then worked for CDC, the World Health Organization, and traveled all over the world setting up disease surveillance systems, which was amazing. And then about 24 years ago, was recruited by the U.S. Navy to help start and lead a clinical research program to continually improve the health and welfare of Navy dolphins.
Dolphins? That's incredible. How fun. Did you get to hang out with the dolphins?
Yeah, it was great. So little confession, I don't know how to swim and I'm terrified of water. So didn't know that was going to be my track. Yeah. But yes, loved hanging out with the dolphins, but they put me into a super secret classified space. And so to be able to work with an amazing collection of data. So this is a half a century of data, health data collected on the Navy dolphins, for the sake of helping the Navy dolphins. And they had archived serum on the dolphins throughout their 30 to 50-year lives, minus 80%. I know you can appreciate this, right? Yeah. So throughout their entire lives. And as I was working there, we were increasingly appreciating that Navy dolphins live a lot longer than dolphins in the wild. Right. In the wild, dolphins live to about 20. At the Navy, they're living 50 to 60 years old.
Whoa. So it's 3 times the lifespan of a Navy dolphin.
Yeah.
Incredible.
Amazing.
Is part of that because there's no predators in the Navy dolphin community?
It is. I mean, it's almost like looking at a developed versus a developing world where
sense.
They have access to great health care, and not quite next health level, but they have a good quality of life. And so all of those things help them live a long time. And because they were allowed to get older, and it's this sustained population of 100 bottlenose dolphins, because they're allowed to get older, we saw that about 1 in 3 were developing aging-associated diseases like high cholesterol and chronic inflammation, fatty liver disease, even the full suite of changes consistent with Alzheimer's.
Really?
Yeah.
That's so interesting. So these dolphins that are living and getting these chronic diseases, was some of that attributable to what they were eating, to the amount of movement they have? I'm thinking about humans. We get these diseases because we become more sedentary. We eat junky food. We don't sleep as well.
Yeah.
Is it similar reasons?
We went down that same path, and it was a lot of this was thanks to working with healthcare providers for humans. Right? It's kind of like we're all working on large-brained, long-lived mammals, right? And that are developing naturally the same as aging-associated conditions. The gift we had was that it was a very controlled population. All they eat are fish. So we didn't have a complicated frame. But they do get to swim and exercise every day. They live in San Diego Bay. So we were able to narrow it down to something. We wanted to do something that we could act upon. So we started at the diet, and so we did metabolomics, and we looked at thousands of small molecules present in their blood, but also in their fish, and went to see which small molecules predicted the healthiest aging dolphins. Again, going back to that invaluable archived serum, and we found surprisingly that the top predictor of the healthiest aging dolphins was C15, which is this odd chain saturated fat I had never heard of.
Wow, that's incredible. So it's the most incredible study ever done on a mammal, right? If you put 100 humans in one controlled environment, feed them the same thing every day for 50 years, and have them exercise the same amount, I mean, the data you can get from that is mind-blowing. It is kind of interesting to note, though, that they all ate fish and they all exercised and moved around the same amount, but they still develop some of these diseases of aging, like Alzheimer's, you were saying, and cardiovascular disease as well.
Right. Yeah, exactly. And so where we started seeing, then we dove in, right, to say, okay, what are the differences? Why do some dolphins have higher C15 than other dolphins? And a couple things happened. In the late 1990s, up until the late 1990s, the Navy had fed the dolphins a super fatty fish called eulicon. And they're so fatty that you could dry them out, stick a wick in it, and they'd be candles. So they would call them candlefish. Wow. So this fishery died out in the late 1990s. So the Navy lost this super healthy source of fatty fish for the dolphins. So they moved to a collection of 5 different types of fish. And so some dolphins were getting, so it ends up 2 out of 5 of those fish had C15, 3 had no C15 in it. So then we ended up having this experiment, like you said, kind of a dream experiment, unknowingly, that some dolphins were getting the fatty fish with C15 and others were not. And it divided a population that then over, a decade were getting either a higher C15 or a lower C15 diet.
Why would some of the fish have the more C15 than the others? Were they separated into different areas of the research?
I think it was the type of fish. So, the types of fish they were getting, things like herring and mullet and mackerel just naturally have high C15 in them, especially the heads and the skin, the parts of the fish we don't tend to eat. While there was a type of fish that was really common called capelin, really low fat and commonly fed, and those had no C15 in it. So the different types of fish will have different levels, which is really interesting. But now they're having a harder time, just in general, finding fish that are fatty enough to have the C15 levels they used to, 30 years ago.
Wow. So dolphins need this special type of fat called C15 fat, which is a saturated fat, basically, right?
Right. That was the other surprise.
Yeah,
right?
Exactly. And when they get more C15 fat, what happens?
Right. So then the question was, what if let's take dolphins and let's take the ones that are what we call poor agers. And they had this combination of aging associated conditions. And let's purposely give them the fish that are higher in C15. Right. So we did that study twice, which was because you show something once, that's great, but you really got to
you have to
repeat
replicate it, right?
Yeah. So we did that, and all of this was funded by Office of Naval Research funding. And when we gave dolphins a higher C15 diet, first their C15 levels increased, which we'd expect and is good. Most importantly, we saw a couple of remarkable things. One is that every dolphin that had chronic anemia resolved within 1 to 3 months. Importantly, when they went off the high C15 diet, Darshan, the anemia returned. So that became a big hint to us that C15 was really critical. Specifically, what we were seeing is it was stabilizing red blood cells. As we get older, right, our cells become more fragile, including our red blood cells. Sure, you start seeing decreasing hemoglobin, increasing red blood cell distribution width. In people, we see the same thing in dolphins. So we also saw lower cholesterol, triglycerides, normalized insulin. So we saw a lot of hints. And then additionally, decreasing ferritin, a marker of what we learned, a marker of iron overload.
Yeah. Yeah. So interesting. So the biomarkers improved within a few months of taking more C15.
That's right. Mm-hmm.
Amazing. And so do they live longer? Do they live healthier?
Well, there is, those longevity studies take some time, but yeah,
Exactly.
they have an increasing percentage of their population that's old and healthy. So, at that point, it was really about, we gave them higher fish, the C15 went up, but it was higher, it did include fish. So there were other components too. It was at that point that we then moved C15, pure C15, into the lab to then thought we were going to be developing C15 as a drug because for fatty liver disease.
Right.
We were seeing fatty liver disease pop up in dolphins. It was matching exactly from a pathophysiology standpoint that of humans. So we moved C15 into the lab, worked with Dr. Ed Dennis, who's a leader in fatty acids. He happened to be in San Diego, which was great.
Yeah.
He was an editor for the Journal of Lipid Research for 15 years. And so we worked with Ed to do 8 studies over 3 years to show that pure C15 is not just associated with better health, but has a direct cause. So we figured out the mechanism of action, bioavailability, how in vivo efficacy, all these things that you need to do if you're going to advance a drug. And now more and more people are doing this with nutrients, as you know.
Yeah, which is great. I mean, finally, like nutrients are getting the same amount of science as drugs do.
Exactly, right? And then it's even better because then they're more likely to be safe because, right, there are things that nature made and that we're supposed to have.
Exactly. It's like all the benefits with minimal side effects.
That's right. That's right.
And so now I know dolphins are very similar to humans because they're mammals, but a lot of similar biology. But how does the dolphin research translate to humans?
Right. So then that was the question. So my main job was to ensure the dolphins' health. So they were like, great, this is doing great. But of course, the public health side of me started kicking in and seeing, could this be relevant for people? At the same time we were making these discoveries with the dolphins, their increasing number of studies started coming out, large-scale prospective cohort studies showing that people with higher C15 have a lower risk of developing type 2 diabetes, of cardiovascular disease, specifically coronary heart disease and heart failure. And so when we started looking into the literature on C15, it was like, oh my gosh, that same pattern is existing for humans. Why is this not received a lot of attention? And the reason is these studies were really to show that saturated fats are bad.
Yeah.
And so what they found in those studies were that even chain saturated fats like C16 and C18, higher levels of those were associated with a higher risk of heart disease, of type 2 diabetes, and that was the headline. What was buried in the study was, oh, and by the way, higher levels of these odd chain saturated fats like C15, C17 were associated with a lower risk of these diseases, but they're not really important. The main headline is saturated fats are bad.
It's super interesting because, the saturated fat studies, so many of them, thousands of them, I think. And it's so interesting that they actually did break them down into the different chains of the fatty acids. I didn't know they did that.
Right. And it was just, again, so buried. And then when you go looking for it, and it's just, one thing that, we share is sometimes it just takes a change of perspective.
Yeah.
And that dolphins gave us the change. The support, the initial support was absolutely showing up on the human side. So once we started seeing that, we're saying, okay, we're seeing the same associations. We're showing in the lab and pharma-based approach that are for humans, right? That it's beneficial. These were human cell-based studies, dose-dependent, activities that are relevant, activating PPARs, activating AMPK, inhibiting mTOR, like all these activities we want to hear. If you want to support long-term health and longevity, this is what C15 was doing. So that's when, and then since then, so if you fast forward 10 years, 100 peer-reviewed studies since our first discovery, now the world is working on C15 and, it's been validated. We had introduced it as meeting the criteria, the first essential fatty acid to be discovered in over 90 years since omega-3 in that initial paper. Now there have been multiple teams throughout the world who have challenged, right? Is it really an essential fatty acid? And then challenged it, used the appropriate hallmark models of nutritional deficiencies, and then Darshan showing wonderfully, it meets the criteria of an essential fatty acid.
It's an essential fatty acid.
Yeah, so it's playing out, which is
so interesting.
Amazing.
Yeah, so this is like, for the listeners, it's analogous to like the omega-3s. Like everyone knows omega-3s are essential. Yeah. It's hard to get it in your diet unless you're eating a ton of fatty fish and nuts and things like that. So this is the next essential fatty acid that you found called what is the scientific name for it?
Pentadecanoic acid.
Okay. Or C15.
C15. We're just going to go with C15.
We'll just go with C15. And so one of the things that I want to highlight on the science of this too is you have these fatty acid chains basically, right? And there's even numbers and odd numbers of them.
That's right.
And so it sounds like the odd number ones are healthier than the even number ones. And why is that?
Right. That's a huge question. And that was, a big reason of why this became a big discovery, because even when we were working with Ed, with Dr. Dennis, it was kind of like, well, is there really going to be a difference between what? And then you're even skipping carbon. So C16 is bad. 15 is good. 16 carbons are bad. 17 is good and 18 is bad again. But what we now know is there are a couple reasons. One is that when saturated fats are metabolized, they're always metabolized by 2 carbons. So it's 16, 14, 12. And so they're always an even chain fatty acid in general stays even. And when it gets metabolized down to acetoacetic acid, which is pro-diabetic, while the odd chain ones are metabolized down to C3, which is propionic acid, which is anti-diabetic. So, that has a lot of health benefits. That's what Food for and All, they had published the reasons for why these are different, which makes a lot of sense. But when we have thrown these different fatty acids against receptors, and now other teams have used them in vivo models, they've shown that if you give a mouse a bunch of C16, it will become pro-inflammatory, be more fat in the liver. If you give it C15, it's anti-inflammatory and so it has these opposing effects, in part by C15 inhibits JAK-STAT, for example. It repairs mitochondrial function, while C16 does the opposite. It activates JAK-STAT. So that's how specific nature.
So interesting.
Yeah, isn't it incredible?
Really incredible.
Yeah.
So that then leads to the question, like, where do people get more C15 in their diet? And where are people getting like C16 or C18 in their diet? Is it the types of foods that have different like chains of fatty acids in them?
Right. So this is where the challenge is. It's that every food that has C15 in it has C16 and C18. So it kind of all goes back to the milk story. So our primary source of C15 is dairy fat, by far.
Got it.
And in fact, there are a lot of studies about C15 prior, because C15 is used as a biomarker of how much dairy fat we eat.
Oh, I didn't know that.
So it's
really?
so we were lucky that there was a lot of science around it. No one just knew that it was an active fatty acid. So that's how. And again, an essential fatty acid, something that we must have, is something that is strongly influenced by what we eat. So it makes sense it was a biomarker for dairy fat.
Got it.
As we've decreased our intake of whole dairy fat, our C15 levels population-wide have been decreasing. And so what we're seeing, the patterns we're seeing in the rest of the world, is that decreasing C15 levels are, again, like I said, are associated on the flip side, an increased risk of type 2 diabetes, heart disease. And now that we know that C15 can actively fix these things, and we now know that a core role of C15 is to strengthen cell membranes against aging-related breakdown, that what we published last year is the proposal of, obviously, if C15 is essential, if you don't have enough of it, that means there's a nutritional deficiency. And so if there's a deficiency, then there should be a syndrome associated with it. And that's where a culmination of the last decade of work, we've been able to detail the specific pathophysiology of if you don't have enough C15 in your cell membranes, they become fragile. It causes a new form of cell death called ferroptosis, which was ferroptosis,
okay.
yes. Yes, exactly.
Ferroptosis.
Ferroptosis. And this was actually discovered, this new form of cell death was actually discovered by scientists at Columbia University back in 2012. There have been 20,000 papers written on ferroptosis. I had never heard of it.
Wow.
Just in the last 2 years, 10,000 papers written on ferroptosis. And we now know that it accelerates aging, it accelerates the onset and aggression of type 2 diabetes, heart disease, these exact same diseases we're seeing. And so when you put the whole picture together, we've been able to describe, thanks to the dolphins, low C15 in the cell membranes, cell becomes fragile. It results in this new form of cell death called ferroptosis that then has an impact on iron overload in the liver and then has spillover effects of increased lipid peroxidation, iron overload, seeding the brain, the heart, the liver, and causing this accelerated aging we're seeing in younger people.
Wow. How is ferroptosis different than regular cell death?
Right, because we were taught three, right?
There's apoptosis, right?
Necrosis and autophagy.
Autophagy.
So we have those three, and so it's kind of a big deal.
Yeah.
When you
it's
find
like a new
a fourth
term for me. I actually never heard of it before.
Well, hey, okay, that's bragging.
I'm learning something really good. I'm learning a lot here.
So ferroptosis. So it's specifically it's described by Dixon et al. In 2012 as they were seeing cells that were under the microscope where it was fully intact, but all the mitochondria were dead and the nucleus looked fine. And so there was this strange unwanted iron inside the cell. So it's very distinct and therefore different looking than the other three types of cell death. And so what they discovered is ferroptosis is caused by fragile fatty acids in the cell membrane, their words, right, not ours, that then are susceptible to lipid peroxidation. That lipid peroxidation then combines with the free iron in the cells. That then leads to massive reactive oxygen species, takes out the mitochondria, kills the cell. And so there's all these details, and it's almost so complicated, we've missed the big picture of all the little mechanisms of how it works. And there are things that can benefit. CoQ10 can help with it. Vitamin D can help. But it's like within the mechanisms, what the dolphins taught us is the same year that ferroptosis was published, we had published this phenomenon in dolphins. We just didn't know it had a name.
Yeah.
And we were able to show that it was because of C15 deficiencies. Because is, again, a very, like you said, a dream model that has shown us we have a real opportunity to, like, vitamin C deficiency and scurvy and vitamin D deficiency and rickets. We have a real opportunity to have meaningful impact on global health.
Yeah. I mean, and you said so many pathways, like you said, the mTOR pathway, the AMK pathway. It sounds like it's like really affecting a lot of the pathways of aging. How does it do that? Like, how does it affect all these different pathways of aging?
Right, and that's a big question. That's when Nick Shork came into our world. So Dr. Shork, he's the head of NIH's Longevity Consortium. Right. And he's been in that role for over 20 years. And though he looks like you all do, young, very young, so something's working.
Probably taking C15,
there
right?
you go, it's Patty 15, in the last 6 months. So Nick, he leads this consortium of the world's leading researchers in anti-aging and longevity. And so they've seen everything under the sun, right? And so much encouraging news on so many fronts with regard to, so it's not like C15 is the only thing. There's lots of advancements in healthy aging, anti-aging. When Nick saw the studies coming out on C15 and seeing all the things that you just said, wait, it's doing this, he said, Steph, I bet C15 is going to qualify as a geroprotector. And I was like, that's great, because you're excited. I'm like, what's a geroprotector, as you know? Yeah. And so that's when Nick explained to me, he's like, Steph, geroprotector is a molecule that can slow the rate at which we age to stem the onset of the diseases that kill us. Right. So he said it's having an impact high up enough the chain that it can have all these downstream benefits. Directly inhibit mTOR, directly activate AMPK, right? And so and stabilize the cell membrane. And he says, and that's what an essential fatty acid should do. We know all the things omega-3 does, right? So if it's essential, it should be doing all these things. And if you think about it, we have all these receptors in our bodies and these pathways in our bodies. They're intended to be inhibited and activated by things to which we're supposed to be exposed, right? And so it's not, our bodies have them there for a reason, and we're realizing that one of those reasons is the need for C15.
Wow. It's so, a lot of people, they look at the supplement industry with a lot of skepticism, of course, right?
It's earned. Yeah, it's been earned.
Right, exactly. There's so much junk out there. There's so much stuff that's like a waste of money, but we're living in this incredible time where you can do the biochemical research and, your research on this captive population of dolphins. I mean, it's a dream research model, and really prove out certain compounds like C15. It's revolutionary because it gives humans another way to think about, like, what are they putting into their body, right? You can put drugs into your body. You have supplements. And there's certain core supplements I talk about with all my patients, like vitamin D, of course. Omega-3s has always been a core supplement for most people. But now we can add some of these other geroprotectors in there that can be revolutionary. And people need to, I think, get over some of this supplement anxiety that they have, because there are supplements now that are backed by science that can have an outsized effect by taking them. Yeah. And I put that in this category now. So I take this every day, like I told you, since I heard of it, and I did some research into it. And I'm so glad to learn about it even deeper with you today. And like urolithin A is another one that I take. I feel like there's a ton of great research around it, improving mitochondrial function and the number of mitochondria that we have. Nicotinamide riboside is another one. But all these like little molecules that at a cellular level can really help us geroprotect, like slow down the aging process, avoid disease. I think it's revolutionary. And, this definitely falls into that category.
Oh, that's great to hear. And it is wonderful. And again, it's not a one-stop shop, right? But there are core, like you said, there's a core combination of molecules of supplements that really have stepped up to the plate, have done the work, right, of being able to understand from the basic level, even understanding dose dependent and just simple things like bioavailability and then knowing what activities, what concentrations you need to reach in order to be able to have these benefits and then experiencing the benefits, right? And that's, in the end, like for us, the Navy asked us to develop, funded us to develop a pure C15 ingredient because of the difficulty of getting, for them, they were having a hard time finding fish that had adequate C15 for the dolphins. So it was developed as a supplement for the dolphins. And now we kind of have that same challenge on the human diet side. And even things like, even if you eat whole dairy fat, which I don't shy away from butter, and I have a flat white in the morning. But even whole dairy fat, if a cow is fed corn, it has half as much C15 in its dairy fat than if it's fed grass. So the more we can understand how to get healthy C15 into our diet, the better. And so this, having a pure form, enables us to have control over getting a bioactive, the most concentrated bioavailable form, of a bioactive nutrient. So all the ones you listed are in that, that same category.
This whole history of saturated fat, it's so mind-blowing, like
I know.
It's so nuanced, and we were making these crazy, massive decisions as a food system, like going from whole fat dairy to 2% and skim milk, and now we don't get enough C15, and now it's like, the cows that we get our milk from are not even fed grass anymore, and so they don't even make it. It's just mind-blowing what's happened to our food industry.
It is. It's crazy, and we're seeing, like even a lot of science is coming out now from other groups around looking at infants and pregnancy, and they're showing the more C15 mom eats translates to how much C15 she has in her milk.
Yeah.
That then the more C15 baby gets, there are now 2 prospective cohort studies that have been done showing that the more C15 babies get from their mom's milk, the better their body growth, the better their brain growth. And then there's a group in France, the Eden cohort study, following kids 3 to 5 to 6 years old, showing they have better overall cognitive development. It's association, but it fits with the experimental studies that have been done in rodents and others, that it does help with, it's essential.
That's incredible. I mean, it's such an important piece of information that is just now coming to light, I feel, even though there's been lots of studies around it, it sounds like.
Yeah. And again, it's, the hard part is, over 100, peer-reviewed studies, but a lot of them, it's the buried, story is because the main story is
saturated
fats are bad and it's C16. And then when you look and it's like, but increasingly, pentadecanoic acid is actually becoming the title of the paper because people are starting to understand, and wonderfully entirely different groups, people working on cancer, people working on Alzheimer's, people working with children's development. They're all now working, and of course, Nick's Longevity Consortium, right? They're all working with C15. So there's about an average of 1 new paper on the benefits of C15 coming out each week.
Oh, amazing. Mm-hmm. Okay, that's good news, because now I think the more we learn about this, the more we can start incorporating it as an essential supplement now for people. So, and just for people, I always have the conversation around supplements versus getting it in your diet. So you can get in your diet with full-fat dairy, of course, but it has to be organic, grass-fed dairy. Mm-hmm. And so even if you have 2 full glasses of grass-fed milk every day and you're having butter, are you getting enough C15?
So there are a couple limitations. So I would say, yes, your C15 levels are going to rise to the levels that would not be deficient. Right. And so the fact that if the hypothesis is our health is getting worse in part because we've decreased our intake of whole dairy fat, I'd be hypocritical if I said, nope, drinking milk isn't going to fix it. I do think it's going to fix it in kids. I think if we get whole dairy, high quality, whole dairy fat back to our kids, I think we can fix a lot of this accelerated aging. I think Dr. Hyman just covered talking about kids getting increasing numbers of kids having hypertension. Yeah. Right. I think we're thinking 6% of kids who aren't obese have hypertension. Like, it's just
mind-blowing.
What's going on. So let's fix that. Let's not be deficient. And then with studies that have been done, I think as we look at adults. So if we look at mammals, all mammals drink milk at birth, right? It's like nature's perfect food.
Yes.
We're the only ones who keep eating dairy after development. So there's a little thing to learn there. But what we're understanding is that, if studies that are done for example, Bishop et al. Did a study on mice with diabetes and high-fat diet-induced diabetic model. And if you give that model C15, you see a decrease in inflammation, decrease in glucose, decrease in insulin. If you give that same mouse model a dairy fat, just pure milk fat, it gets worse. So there's increased liver fat, increased inflammation, and they're attributing it to the much higher load of C16. Mm-hmm. So I think in the younger years, I think good quality milk can help fix this pandemic of deficiency of fructose in our youngest years. As we move to our oldest years and then wanting to optimize our C15 levels, like our Sardinians have 3 times higher C15 levels than the rest of us in the blue zone. They have sheep, local sheep and goats. The grass-fed.
Right.
ends up high altitude grass. That's actually the highest C15 ends up in the highest C15. So this is trifecta world, and their cheese, one of their cheeses, which is pecorino, highest C15
pecorino
cheese.
It does.
Yeah,
okay.
so pecorino is a good addition.
I love pecorino cheese
to the diet.
Yeah.
And they have replaced a lot of their meat with cheese. So they just have that perfect environment for high C15. So Sardinia is an example of how you can get it. For most of us, I think that the pro-inflammatory fats in dairy fat can outweigh the benefits of C15. And there's another hypothesis that, like, for example, mice that are fed a lot of a high-fat diet, including C15, their C15 levels actually go down. And the hypothesis is it's because it's competing with the other fats. And only 1% of dairy fat is C15, 40 to 60% is C16, C18.
Got it.
So that's why Navy said, hey, can you produce this pure C15 so that we can just get that, make it more bioavailable than what's in food, and so that we can get to the levels we need.
And where does fatty 15 get the C15 from?
So we take because we want it to be plant, because we're like, gosh, if we're going to make it pure, we're going to make it bioavailable, let's also make it vegan friendly.
Okay.
So we use a plant-based C14, and we add a carbon onto it.
Oh, okay. So you get a plant-based C14, and then you add a carbon through a chemical process, and then it's pure C15.
99.9. Sometimes it's 100%. Even after 3 years, it's a very stable molecule. So.
And you've given this to the dolphins, and they're living better, longer lives.
It's pretty fun, isn't it?
I love it.
Yeah.
Have there been any human studies on the C15?
Yes. So there have been. So there have been 6 clinical trials involving C15. 2 of those are with pure C15. The same ingredient as what's in fatty 15. Okay. One was fatty 15. And those have shown that if you take C15 and you get to the levels above this threshold of it's 5 micrograms per mil in the blood, then in one population they showed a decrease in ALT and AST in a population that had started with high liver enzymes, so improved liver function and improved hemoglobin levels, as we saw in the dolphins. The second study showed a decrease in LDL cholesterol and improved gut microbiome, including Bifidobacterium adolescentis. So that's will be a fun one to explore.
Yeah.
There have been skin studies looking at like a high algal C15 supplement showing improved skin health on all parameters that they evaluated. And then a recent study, Argovani et al., it was a high-fat diet study where they actually put them on a high-fat milk diet. And they showed that if they had more than 4 high-fat servings a day, this was a crossover controlled clinical trial, their C15 levels went up. And as those C15 levels went up, those were correlated with improved vascular function, so of less stiffness, of the measure of stiffness. However, the higher levels of C16 were correlated with an increase in blood pressure. So that's another example of how milk can, it's good with the bad, but we do need to get our 15.
Yeah. Interesting. And so do you see more studies being done with C15 in humans? And I'm sure you know of many of them.
Yeah, there are two big ones planned for next year, good. So stay tuned. And increasingly more and more independent teams are working with C15. So sometimes we find out about the clinical trial because it got published.
Yeah.
The one with
there's a study on this.
Yeah, the one in cholesterol was done in Singapore. So it's great that the world is turned in looking at it.
Yeah, and so you measured. You said you measured C15 levels in humans in 5 milligrams per deciliter.
5 micrograms per milliliter.
Okay, got it. Can someone get this lab test commercially, or is it something? Yeah, you can.
You can, yeah. So most fatty acid. I should say an increasing number of fatty acid panels are including C15.
Oh, great.
So you may be measuring it and not know it. That happened with Dr. Hyman. He went back and looked. He's like, oh my gosh, I can't believe how many. He went back and looked. He's like, I can't believe how many of my patients had low C15. I didn't even know to look at C15 until now. So that's been happening at a few with a few groups, but it is increasingly available. We did partner with Genova, and we did a at-home blood spot test that people can use. But ideally, you go to your functional healthcare practitioner and you get the whole fatty acid blood panel. So you can see not just C15, but you can look at all your fatty acids.
Got it. And then when you're looking at a fatty acid blood panel, you're looking at C15, C16, I assume. Are you also getting your omegas as well?
That's right.
Got
Yeah,
it.
exactly. Yeah. So, and then usually they'll report it as a percentage. So the easiest guide is you need to have greater than 0.2% of your fatty acids. Greater than that gets you out of that nutritional deficiency zone.
Right.
Sardinians are at 0.4 to 0.6%.
So that's optimal.
Yes, exactly. So you have not sick, and then you have the
Optimal,
longevity. We call it the Sardinian longevity zone level.
And that's what you want to aim for is 0.6 as a level?
0.4 to 0.6. Yeah, I'm at 0.5, and it's a combination. It's supplements, but I also, like I said, I have high quality dairy fat too.
Yeah. I have to check all our blood tests because I don't know if we're testing for C15, but if we're not, we're going to start doing it.
I know it'll be really fun to see, and it's always nice when a biomarker is also the therapeutic.
Absolutely, yeah, because then you can directly track how much replacement you're getting.
That's right.
Very interesting. So what do you see like future therapeutic uses of C15 being?
Oh gosh.
Besides neuroprotection.
Yeah, exactly. I think it's, it will become a core, just like vitamins, right? That you need to have certain levels. A lot of vitamins now, there's deficiencies are actually not very common. I think it's going to be increasingly understood that C15 is a common deficiency. It's fixable. We can fix it on many levels. We've talked about dietary guidelines and increased, agricultural practice, supplementation through testing. So I think that's going to be a huge area. We're focusing on two areas. One is cognitive health. So, of course, and so we just did a study that we published earlier this year showing that C15 inhibits MAOB, MALB, and FAAH, which can help, as a result, increase and support higher dopamine and endocannabinoid levels. So it helps explain why, myself included, better sleep, calmer mood, and because we're like, why are people experiencing this? And now the science has caught up.
So interesting.
Benefits, yeah. So it's
wonderful. Well, I mean, this is definitely part of my core supplement regimen. I'm excited to have you on because, I have a lot of my patients starting to take it as a core supplement, and I wanted to point them to a podcast episode as to why.
That's good. Well, this worked out well.
Yeah, exactly. So this is great. I could just be like, listen to this, and you know why now. I'm really excited that you have a new version of it as well, right? A physician practitioner version. Can you tell us a little bit about that?
Yeah. So because we're seeing, with regard to, especially under healthcare practitioners' guidance, that there might be people who have a greater need for higher doses of C15. They want to get a kickstart. They're vegan. They have some of these underlying conditions that we talked about, right? So to provide more specific support in certain areas, evidence of ferroptosis, right? So if you have high ferritin and high RDW, that would be another patient population. So because of that, we came out with a higher dose C15, what is called Advanced Formula Extra Strength Fatty 15, that is exclusive to healthcare providers.
Okay.
Excited to have that available. In fact, you are the first to have it right here.
Oh, amazing. I'm excited. Thank you.
You're welcome.
I'm going to put myself on it. I don't have a high ferritin, but I'm still going to put myself on it.
That's right. I think Sardinians have a lot to teach us, so we just want to get those levels and without.
Get them
it'd be
optimized.
nice to live in Sardinia, but we can't all do that.
I always wonder why I don't live in Sardinia. No, this is fantastic. Well, I really appreciate you making the drive up here from San Diego and talking to us about the dolphins and C15. And I'm really excited about having this in our toolkit now to protect our patients from aging, and it's going to be, it's a part of my core supplement routine. So I appreciate you coming to talk to us about it.
Dr. Shaw, it's been an absolute pleasure.
Thank you. Where can people learn more about this?
Sure. So they can. Simon & Schuster came to me and said, "Steph, we've been reading your science about C15. Write a book." And so all of these studies, because the science gets real dense, is now in the longevity nutrient that came out in this last March, and then paperback will be coming out this March. It's now been published in 6 languages, which is fun. So the global movement is on. So you can get the longevity nutrient wherever books are sold. And then fatty15.com, you can learn about the supplement there. Of course, they could come talk to you. And then all the science, all that peer-reviewed science, we've put them all in one place, which is at discoverc15.com.
Okay.
And that's where and you can go to the resources page, and it's divided out by category of areas of longevity and essential fatty acids, pregnancy, things like that.
Great. Well, thank you so much for joining me today. Look forward to continuing the discussion with you guys.
We're going to be learning together.
Yes.
So this was such fun. Thank you.
Okay, thank you.